Hello everyone. Today we are going to do chapter number 5 from the Curiosity book, and the name of the chapter is Measurement of Length and Motion. Okay students, so all of you are excited to learn this chapter. So let us start. Now here we have a story of an 11-year-old girl whose name is Deepa. Where does she live? She lives in a town in the state of Haryana. So the new year has started, the new session of the school has begun, and now Deepa, because she has grown tall, she needs a new uniform. So her mother takes her to a tailor's shop for measurement of the new uniform. And there she sees that the tailor is using a metal measuring rod, okay, to measure the length of the cloth. Okay, why does he measure the length of the cloth? Because Deepa's mother asks for 2-meter cloth piece. So the shopkeeper takes the measurement of the cloth piece using the metal measuring rod. Okay, now the tailor takes her measurement using a flexible measuring tape. Okay, now her mother also instructs to the tailor that you increase the length of the uniform by 4 angula. 4 angula means 4 fingers width. All right, so all this is happening. While all this is happening, Deepa is thinking that are the tape and the rods similar to the scale she has seen in her elder sister's geometry box? And she's also thinking, what is the meaning of 4 angula? So all this is her thoughts going on while her mother is just talking with the tailor about her clothes. Okay. So this experience of Deepa, she goes and share with her friends. Okay. So you see, they are discussing with each other what has happened in the tailor and the shopkeeper's shop. Okay. So now what let us see what they are discussing. Hardeep, who's one of Deepa's friend, he says, I have seen my grandmother measuring cloth by the length of her arm. Okay, so a lot of people measures cloth using the length of their arm. So this is a very old practice of measuring length. As you can see, Hardeep's grandmother is measuring the cloth by the length of her arm. Okay, then this says, have you ever seen how farmer measures length to divide his field into beds? He walks and counts the number of his stride, says Padma. Oh, not just the length of the strides. Sometimes they also use the length of their feet to measure, adds Anish. Deepa says excitedly, measuring length using body parts must be so much fun. Let us also measure something using a body part. So now they're very excited with the fact that people are measuring the length using their body part. Grandmother is using measuring the cloth with the length of her arm. There is a farmer, he's using footsteps or strides to measure the length of their field. So they're very excited and they want to check how they can measure the length using their body parts. Okay, so now they're thinking what we should measure. So they decided that let us measure the length of the table in our classroom. Okay, who says this? Tasneem. So Padma says, and which body part should we use to measure it? Then Deepa says, let us use our hand span. Children, do you know what is a hand span? This, if you can see in this image, we are using the hand span to measure the length of this table. All right. So she says, I will show you how to use it. I have seen my mother using it. She calls it balisht. Okay, so it is called balisht. Hardeep says, okay, let us also note down our measurements. And then they decide to measure the length of the table and write down their measurements. Okay. So here you see they have made a table where the name of the students are there and number of handspan. So you see Anish, according to Anish, number of handspan is slightly more than 13. According to Padma, it is 13. According to Tasneem, it is slightly less than 13. According to Deepa, it is between 13 and 14. For Hardeep, it is 14. So now Padma says the number of handspan is different for all of us. All right. So what we can say about the length of the table? They're not sure because each of them is getting a different reading. All right. So they think, why should the number be different? Hardeep thinks, Then Tasneem says, I can guess our handspans are of different sizes because students, our hands, my hand and your hand will not be of the same size. They are of the different size. Your hand and your friend's hand will not be of the same size. It will be of different size. And hence, if you measure the length of any object with the help of your handspan, obviously it is going to give you a different reading. So now Anish gives an idea. Let us check this. So all five of them put their handspan along each other and arrived at the conclusion that the lengths of their handspans are different. Okay, so now Deepa says thoughtfully, no wonder people use scales and measuring tapes. Okay, so now she has come to the conclusion why we are using scales and measuring tapes instead of using handspan or length of our arm. Okay, or steps of the foot. Why are we not sticking to the old conventions of measurement? Why are we bringing into the new? We are taking the new convention like measuring tapes, like scales, etc. Okay, so now she has realized this. Deepa and her friend compared the length of the table with the length of their handspans. The length of the table is expressed in terms of their handspan. Here, the handspan used for measurement is an example of a unit, right? One handspan, two handspan, 10 handspan. It's a kind of a unit. And the length is measured in two parts. So always remember, whenever you are measuring a length or for the fact any physical quantity, it will have two things. It will have a number and a unit. For example, let me write it down for you. Suppose you are measuring mass. Okay, so if you are measuring mass, you will have, suppose you bought 1 kg of potato from the grocery. So 1 kg, where 1 is a number and kg is the unit. In the similar way, if they use handspan for the measurement of the table and suppose they get a reading of 13 handspan as given in the book, then 13 is the number and handspan is the unit. All right, so any measurement, okay, whether it is length, whether it is mass or any other measurement, it is expressed in two parts, number and a unit. All right, I hope you all are understanding everything. However, handspans and other similar units such as length of hand, foot, fist or fingers, they will differ from person to person because the sizes are different. All right. Thus, there is a need for such unit for which measurements of the same length made by different people do not differ. So now we need something. Even different people use it to measure. The answer remains the same. All right. So you have a little bit here to know, more to know, which we may discuss at the end of the chapter. All right. Now, let us come to the standard units. So, students, may I know what do you mean by standard unit? You know, several system of units have been evolved with time. Just now we discussed about something called handspan, right? Do we use handspan now? No, we don't. We have some standard units for the measurement of length or for any other measurement. All right. So when people started traveling from one place to another, it created a lot of confusion. This led to different countries coming together and adopting a set of standard units. They decided that we will set a standard unit of measurement and everyone is going to follow that unit of measurement. All right. And that is called International System of Units, which is also known as SI units. All right. So the SI unit of length is meter. What is the SI unit of length? It is meter. And how do we write meter? As in, what is the symbol we use for meter? Is small m. All right. So whenever you are going to measure length, suppose you're writing 1 meter, 2 meter, 3 meter, how you're going to write it? Small m. All right. A meter scale is shown in figure 5.2. This is figure 5.2, and I'm sure you don't need this figure 5.2. You must be having a similar scale with you at your home, right? So a meter scale is shown over here. 1 meter M is divided into 100 equal divisions, okay? So 1 meter is divided into how many equal divisions? 100 equal divisions. Okay, and each division is called a centimeter. Each division is called a centimeter. All right, so you may be familiar with the smaller part of the meter scale. Typically, the smaller part which we carry in our pencil box, that is 15 centimeter long scale. All right, and over there each division is equal to 1 millimeter. So when we have a centimeter scale, the even the centimeter is divided 1 centimeter is divided into 10 equal divisions, and that each division is 1 millimeter. All right, so if you look carefully to at a 15 centimeter scale, you will see it has markings in cm from 0 centimeter to 15 centimeter. All right, the length of any section between two consecutive big marks such as 1 and 2 or between 5 and 6 is 1 centimeter. All right, here we have a scale, if you can see. So you see 0, this is 0 and this is 1. So from 0 to 1, this is 1 centimeter, and this 1 centimeter is further divided into 10 equal parts. Let me take a pen. Yeah, you can see that they are further divided into 10 equal parts. So how many equal parts? 10 equal parts. All right, and the length of one of these smaller part is called a millimeter, that is 1 millimeter. All right, you can say that 1 millimeter is 0.1 centimeter, or you can also say that 1 centimeter is equals to 10 millimeter. As you can see that 1 centimeter is made up of 10 divisions. One division is equals to 1 millimeter. Therefore, 10 divisions, it will be equal to 10 millimeter. Is that clear to all of you? I hope my points are getting clear. If you have any problem, you can put down your doubts in the comment section, and I'll try to help you out through it. All right. So 1 millimeter is the smallest value of the length that you can measure using this particular scale given, 15 centimeter scale. Okay. Is that clear to all of you? Now, for measuring larger lengths, we use larger unit. Okay. So SI unit we just learned. What is the SI unit of length? It is meter. Okay. It is written as small m. Now, if you want to measure larger lengths, okay, like distance between two cities, then in that case we use a larger unit called kilometer, and it is written as small k and m. Now, students, 1 kilometer is equals to 1,000 meters. How many meters? 1,000 meters. So for measuring smaller lengths, we use units like centimeter or millimeter, whereas to measure bigger lengths, we use unit like kilometer. All right, so here you can see 3 relationships are given to you. All these 3 relationships are very, very important, so you guys are going to learn it. But before learning, you should understand how you are getting it. We just saw in a 15 centimeter scale, 1 centimeter was divided into 10 equal divisions, with each division measuring as 1 millimeter. Therefore, 10 divisions is equals to 10 millimeter. So 1 centimeter is equals to 10 millimeter. Same way, we have 1 meter as 100 centimeter and 1 kilometer as 1,000 meter. All right. All do you know sessions you will go through, and if we get time, we will do it at the end of this video. All right. So here you see these two friends are discussing something. What are they discussing? Here, a friend has a question. He says that suppose we all measure the length of the table again, and now we are using a meter scale. So, will our results be different? He's thinking. So, now Deepa says no, the result will not be different, but we should know the correct way of using the scale to measure the length in order to get a correct reading. All right. So, now what are we going to learn? We are going to learn the correct way of measuring length. So students, if you want to measure the length of anything, what are you going to do? You're going to place the scale correctly. And how are you going to place the scale correctly? You are going to place the scale horizontally, not slanting like this one. This is a big no, cross. You cannot place the scale in a zigzag pattern. You have to place them in a straight line horizontally. All right. Or if you want to measure the vertical length, you have to put it in a straight line vertically. All right. Now, in order to measure the object, the reading will be taken from the zero mark of the scale. So we are going to place one end at the zero mark and check where the farther end, the last part of the object reaches to. So if you see here, it is reaching till 9.5 of the scale. Therefore, this object measures 9.5 centimeter. So this is the correct way of placing the scale and taking the reading. And this way you will not be able to get the correct reading because this is an incorrect way of placing the scale. All right. Now, what is the correct position of the eye while reading the scale? For example, if you're trying to measure the length of a pencil by aligning it to with a scale, the position of your eye should be directly above the tip of the pencil. All right. So you see here, there are three positions. A and C are oblique, where B is directly above the tip of the pencil. So which one is the correct position? B. All right. Now, how to measure the length if the ends of the scale are broken? Sometimes what happens? The scale are broken, right? Maybe in a fight or mistakenly, if we break our scale, then in that case, how can we take a measurement? All right, so let us see if the end of the scales are broken or zero marking is not clear. Sometimes the zero print also comes off. Then in that case, with such a scale, use any other full mark of the scale. Say 1 centimeter. Then you must subtract the reading of this mark from the reading at the other end. What does this mean? Suppose you're starting not from 0 but from 1. Then in that case, how much you're getting? 10.5, right? So what are you going to do? You're going to subtract 1 from 10.5 and you will be getting the correct reading, that is 9.5 centimeter. Similarly, if you start the measurements from 2, then in that case, your reading might come at 11.5. Okay, so what are we going to do is 11.5 minus 2. Why minus 2? Because we are starting from the number 2. Then in that case, we are going to get the reading as 9.5 centimeter. All right. So here they have taken precisely 10.4 or 9.4. I'm taking it as 9.5. All right, or 10.5. You can take anything. So understood how we are going to use a broken scale? Clear? Here is an activity. What is the activity? Let us see. The activity says you select any objects around you, such as a comb, a pen, a pencil, an eraser, and what do? You measure their lengths. Okay, and once you measure their lengths using a meter scale, you note them down. So you take 1, 2, 3, 4 objects and measure their length, note it down and see how the length of the different objects are different. All right. So while writing the length, you do not forget to write the unit. Suppose you're using a centimeter scale, so your answer may come in centimeter. So 1 centimeter, 2.5 centimeter, 10 centimeter. So you will be writing the number as well as the unit. As I told you, the result of the measurement consists of two parts. One is the number and the other is the unit. Is that clear, everyone? Now, till now we were discussing about a straight line. How about you have to measure the length of a curved line? Then what way are you going to use? Because scales, the meter scales, they are whether they are made up of a rod or they are made up of a plastic, they are straight, right? So how are we going to measure the length of a curved line? Let us see what the paragraph has to tell us. Anish and his parents, they fixed electric string lights on the arcs of a veranda of their house. As you see, they fixed some string lights over here. Okay, now it is for a celebration. All right. So how would they have measured the required length of the string lights? Now, string lights, how much you need? How did they know? So that they can efficiently decorate their house. So in that case, what you need to do is you have to measure the curved line by using a flexible measuring tape, or you can also use a thread. As you can see in figure 5.8, the person is using a thread. Now with this thread, they will take the measurement and they will put it on a scale and see how much does the thread measures, and then they can easily buy that amount of light to decorate their house. All right, so the thread can be straightened and its length can be measured. How? By using a meter scale. So now we are done measuring the straight line. We also know how to measure a curved line. Now let us see, how do we describe position of objects? Okay, so 5.5, describing position. One day, the teacher informs her students that she has planned an educational visit to a nearby garden. So she asks her student to reach there directly in the morning. Okay, so now Deepa and her friends, they start discussing whether the garden would be closer than their school or it will be far away. Tasneem and Padma says that the garden would be closer, while Deepa and Anish feel that the school would be closer, and Hardeep thinks both would be almost at the equal distance. Okay, so here you see there's a location of bus stand, school, garden and houses of Deepa and a friend. What you can see, this is the school, this is the bus stand. Here first we have Deepa's house, then Anish, Hardeep's, Tasneem's, Padma's, and there's a garden over here. All right, so who do you think is correct? So what are you going to do is you're going to understand this picture and find out who is saying the whose observation is correct. If you see what they are saying, Tasneem and Padma says that the garden would be closer. So you see Padma and Tasneem's house is closer to the garden than the school and the bus stand. So obviously their observation is very clear that the garden will be closer from their house. All right, now Deepa and Anish feel that the school will be closer. So if you see from Deepa and Anish's perspective, obviously school and bus stand is closer to their house compared to Tasneem and Padma's house. All right. So Tasneem and Padma will find the garden closer, whereas Deepa's and Anish will find the school and the bus stand closer. Okay, now Hardeep thinks that both would be almost at an equal distance. If you see, Hardeep's house lies exactly in the middle. So for him, whether to go to the garden or to the school is same because they are at an equal distance. So all of their observations are correct. All right. Oh, I'm sorry. Just a second. All of them are correct. Yes, we just discussed. Why are their observations different? Because they are locating at different distances from the school and the garden. So if instead each of them had thought of the distance from the same object or point, say the bus stand, then their observations would have been same. So they have to take a fixed point that is called the reference point. All right. So when distance is stated with respect to a fixed point or an object, then this point is called a reference point. Very, very important. So a few days later, Hardeep tells his friend excitedly, "Let us all go to the playground. The sports teacher wants us to help her to draw lines with tuna powder." You know what is tuna powder? Tuna powder is nothing but limestone powder. Okay. So why they want to draw lines with this? Because they are making a kabaddi court for the sports day. Okay, now Padma says we will need a longer measuring tape. Let us take it from the sports room. So Deepa said again, let us first decide the point on the ground from which we will measure the distances to start drawing the lines. So let us call this a reference point. So they decide that we will take a reference point from where we will start to draw the line. So this is the reference point, as you can see in the picture. This is the reference point from where they have started to draw the lines to make a kabaddi court. All right. Okay. Now, after a few days, Padma was traveling by bus to visit her grandparents in Delhi. She was eager to reach Delhi and was reading the kilometer stones on the side of the road. Have you ever traveled by road? If you travel by road to far places, you will see that there are, these kind of stones at various intervals with the kilometer is there and the city is there. So what does it indicate? It indicates that to reach Delhi you have to travel this many kilometer, 70 kilometer more. All right. So further on, the next kilometer stone read Delhi 60 kilometer. Okay. So now Delhi was 10 kilometer closer, because now it is only 60 kilometer from where they started. All right. So each kilometer stone indicated that she was getting closer to her grandparents' house. These kilometer stones indicated her distance from Delhi. So Delhi is the reference point in this situation. So they are taking what as a reference point in this measurement? Delhi as a reference point. All right. So in order to take measurements, what is important? It's important to take a reference point. Otherwise, everyone will have a different conclusion about the distance. Just like how the friends had a different conclusion about their distances from the garden and the school. Okay, because they all did not take a reference point. They were measuring it from their home, from their perspective. So in order to take one uniform measurement, we will have to take what? A reference point. All right. So here what is written, let us go through what is written. If the kilometer stone reads Delhi 70 kilometer, what we can say that the position of Padma is 70 kilometer from Delhi. Okay. Now if the kilometer stone reads Delhi 60 kilometer, what we say that the Padma is where? 60 kilometer from Delhi. All right. So Delhi is our reference point. Okay, now we have moving things. Student, what idea do you have about moving things? If you look around yourself, can you prepare a list of 5 objects that are in motion and 5 objects that are at rest? Okay, so here you see there is table 5.3. You have to record your observation, how you have to write down the objects in motion. Okay, and you have to justify your answer how they are in motion. Then you have to write down the objects at rest and again write your explanation how you think that the object is at rest. All right. So you have to do this And once you complete it, you can put it in the comment section. I will check it for you. All right. Or if you have any problem, you can ask me directly in the comment section. All right. So when you do this activity, you will compare and analyze your justifications. How can one decide if an object is at motion or at rest? All right. There has to be a definition of motion and rest, right? So as to you to know that, okay, this object is moving, you can call it in motion, or this object is at rest, you can call it to be at rest. Okay, how do you decide that? So that we will come to know when you go through the chapter deeper and deeper. Okay, so let us see. An object is said to be in motion when if its position changes with respect to a reference point with time. Yes. So again over here you have to consider a reference point. Okay. So suppose if you see that a person is standing on the bus stop. All right. And a car is moving. Okay. The person is looking at the car and then looking at the tree. The person sees that the tree is at rest. It's not moving, whereas it's not changing position, whereas the car is changing its position with respect to the tree. All right. So obviously the car is in motion according to the person who's standing at the bus stop. All right. So I will explain it to you in details. Don't worry. Let us first go through it and then we can discuss it in details. If an object is not changing its position with respect to the reference point, so if it is changing its position with respect to the reference point, it is in motion. Whereas if it is not changing its position with respect to the reference point, then in that case, the object is said to be at rest. So here you get the definition of rest and motion. All right. I will explain it to you with the help of an example and then we will enter into the types of motion. Okay, so students, let us consider a bus. All right. Now, this bus has a driver who's driving the bus, and then we have many passengers sitting on the bus. Suppose I'm talking about passenger A and B. All right. And there is another man who is standing at the bus stop, and let us call him C. Okay. Now, the bus is moving. If you ask the passengers, this person who's standing at the bus stop, C, that what do you tell about A and B? Are they at rest or they are in motion? So this person will consider the surrounding as the reference point and will see that the bus is changing its position with respect to its immediate surrounding, and hence A and B is also changing its position with respect to its immediate surrounding. Therefore, for C, A and B are in motion, right? Whereas if you ask A or B about each other, they will look at each other and see that they both are not changing their position with respect to their immediate surroundings, and therefore they both are at rest. All right. So a body is said to be in motion when it changes its position with respect to its immediate surrounding or with respect to a reference point. Whereas a body is said to be at rest if it does not changes its position with respect to its immediate surrounding or with respect to a particular reference point. So I hope I've made the definition of rest and motion clear to you all. So now let us come to the types of motion. So in order to see the types of motion, what you can do is you can do activity 5.3 and check out. So I'm leaving this activity for you all to do and let me know what are your observations in the comment section. So now directly we will come to the two types of motion. The first type of motion is called linear motion. Children, what do you mean by linear motion? When object moves along a straight line, then its motion is called a linear motion. For example, if you are dropping a bar, okay, vertically downwards, what do you see? That the bar is falling straight down in a straight line vertically downwards. So this kind of motion is a linear motion. All right. Same way you see this boy is pushing this box. So if the boy pushes the box is going to move in a straight line from right to left. So again, this is linear motion. Now come to the example of a tree where an apple or an orange, or maybe this looks like a mango. No, this is an orange. It falls vertically downwards in a straight line. So again, this is an example of a linear motion. You see troop of girls, they are doing march past, all right, but they all are walking in a straight line. So again, this is considered to be a linear motion. So a motion that always takes place in a straight line is called linear motion. All right. Now, if you see that there are objects like merry-go-round or swing where motion is not in a straight line, so these types of motion also called linear motion? No, these type of motions are called circular motions. So here you learn about two types of motion. What are the two types of motion? One is linear motion and the other is circular motion. All right, so you have activity 5.4 to investigate about circular motion. So 5.3 and 5.4, all of you are going to do and let me know what is your observation in the comment section. Okay, so what is a circular motion? When an object moves along a circular path, then such a motion is called a circular motion. All right, you can see example of circular motion here. A girl has tied a stone to a thread and moving it in a horizontal plane. So you see in a circular motion in the horizontal plane, the stone is moving in a circular motion. Same goes for rides like merry-go-round, or you can see this ride. These horses are going to rotate in a circular manner. So the motion is called a circular motion. All right. Now you will also observe a third type of motion, which I have not mentioned over here. I should mention the third type of motion, which is called oscillatory motion. Now, what is oscillatory motion? It is a type of motion where an object does to and fro. What is to and fro? For example, you're sitting in a swing. All right. So when you sit in a swing, how does a swing move? To and fro. Same way, if you have a clock at your home, a pendulum clock, you can see how it moves to and fro. So this type of motion where an object moves to and fro is called an oscillatory motion. So when an object moves to and fro about some fixed position, then that motion is called oscillatory motion. To sum up, we have done three types of motion. One is linear motion, the other one is circular motion, and the third one is oscillatory motion. All right, you can do this activity to understand or clear your concept about oscillatory motion. All right. So here we have another activity, activity 5.7, where there is, you can see there's a playground, and you have to identify in each case what kind of motion is happening over here. Okay, so in the swing you can see that the swing moves to and fro. So what kind of motion it is? It is oscillatory motion. All right, so under oscillatory they have written to and fro. Now straight line. So this girl, she is going over these monkey bars. So how she is going? She is going in a straight line. So that monkey bar you can write over here, monkey bar. Which one is a linear motion, straight line, motion in a straight line. All right. Same way we have seesaw. Again, seesaw goes up and down about a fixed point. So that is oscillatory motion, that is moving up and down. Okay. Same way you will do it for others also. And let me know if you face any problem. Okay, children. So these are the keywords which you should know while you are writing your answers. All right. So that's the end for today. I hope you all understood what I have taught you. In case of any doubt, you can put it down in the comment section and we can discuss more about this chapter. Thank you and take care.